Vector and energy calculus, vector and commercial calculus. This is the discussion that we are pursuing. In that, we are in calculation of divergence or flux density also. Flux density, flux density. But main word is divergence. What is the divergence? What is flux density? Okay, so flux density in the sense, many times I have given the example. Okay, flux density or divergence. Flux density or divergence. What is the flux? Now I have given example. Consider it was something charge. Okay, okay. Anyway, in the name of in the name okay, so in the name of electric charge, okay, this is this is one electric charge. This is one electric charge. Okay, this is electric charge, and this electric charge is kept inside this sphere, inside this ball. This electric charge is kept at the center. Now this ball has center. This ball is centered at origin. This ball is centered at the origin. This is x-axis, this is y-axis, this is z-axis. In that sense, this is origin. Now this ball is centered at the origin. The center of this ball is the origin. It is kept at the origin. Consider there is an electric charge that is kept at the origin. Because of electric charge, electric field is now emanating all around. Okay, how much is the electric field passing out of the surface? That is called flux. Consider there is a liquid, there is a something electromagnetic liquid at the center. From there, the liquid is coming out, gushing. And then, how much is the liquid that is coming out of the surface? It's called flux. If you get the how much is liquid coming out of the surface, divide it by the volume of this sphere. That is called flux density. Flux density. Okay, so flux density means what is the amount of flux that is that is coming out of the surface. How much amount of the electromagnetic, how much is the amount of electromagnetic liquid that is coming out of the surface, and then divide it by the volume. Okay, that is the net flux density it is called. Okay, I have given many times this example. This is a cylinder, and this portion is connected to a pipe, and this portion is connected to a pipe. Both are open, and liquid is coming inside it to the cylinder, and liquid is going out of the cylinder. What is the flux? What is the flux? Flux means how much is liquid that is coming out of all the surface. This through this surface, nothing will come out because liquid is flowing in this direction. Okay, everywhere the liquid, this if this is the boundary region, if this is the boundary region, then this vector is the area vector. Area vector is always perpendicular to the surface. If this is the surface, if all around this is the surface, then area vector is perpendicular to the surface. How here area vector is everywhere perpendicular to the surface, and they are parallel to each other. If this is the surface, if this is the surface that is flat, then area vector everywhere is perpendicular to the surface. All are parallel. Can you see? Similarly, here area vector all are parallel, but here on this surface, area vector is like this. Okay, if the liquid is entering from here, and then this side area vector is along this direction. This side area vector is along this direction. That is the way I have taken the surface contour, surface perimeter direction. What is the surface perimeter? A surface boundary direction. With that direction, we decide the normal vector. And normal vector is like this. If surface where the direction is like this, the normal vector is like this. If surface where is like this, normal vector is like this. Okay, so if if I'm saying that the surface direction I have taken is like this, see, the normal vector is like this. Now here it will be opposite I have taken surface direction. Okay, whatever comes to your hand, right hand, then it is normal direction. Now, when liquid is entering here and coming out of it, what is the net flux? Here net flux is zero because liquid are vector and area vector is, they are completely perpendicular to each other. If this is x-axis, y-axis, z-axis, then this area vector, what we are seeing now, this is purely in y-z coordinate. See, y-z plane. These all are in y-z plane. This is x-axis, velocity of the liquid is along the x-axis. And area vector is x-axis, this area vector is along minus x-axis. Now the flux calculation is what how much liquid is entering into the area vector. So liquid is entering like this and area vector is opposite. So net liquid into area vector, that is the flux at this side, that is negative. And this side liquid velocity into the area vector, that is the flux, that is positive. If you add these two, it becomes zero. Anyway here it is zero, so net flux is zero. What is the flux density? Whatever the flux we got, divide it by the volume of this entity, that is, when flux is zero, flux density is zero. But anyway, if I keep a charge, if I keep an electrical charge, if I keep an electrical charge at the center of the sphere, an electrical field liquid, electromagnetic liquid is flowing, gushing out of it all around, then how much electromagnetic uh, liquid I can see that is passing the surface. Okay, that is the electromagnetic liquid velocity dot product with the area vector. Okay, so electromagnetic field, the velocity equation is the charge I have kept q r vector divided by r to the power 3 divided by r to the power 3 dot product with the area vector or dot product d of position vector of the, if I take any point p and from the center, if I take a position vector passes through origin. So I take a point at the center and take any point P, and if I make a position vector, then D of position vector is the area vector. So net flux coming out is velocity vector dot product with the area vector or velocity vector dot product with D of position vector. Okay, now anyway, area vector, when we see area vector that is perpendicular to the surface and radial vector, they are in parallel to each other. It may not be true for all kind of surfaces, but for spherical surfaces that looks true. For the spherical, it may not be like, consider this is centered at the origin. Centered at the origin, at the middle there is x-axis, and at the middle there is origin. This is minus x-axis, this is z-axis, this is y-axis. Now if I take any point here, this is position vector. This is position vector. But this is surface area vector. Surface area vector, in this line it is like this or it is like this. But position vector, if you go long, position vector from center it will be like this, where surface area vector is like this. So not necessarily the surface area vector will be along the position vector, but in sphere kind of scenario, wherever you go, the surface area vector is along the radial vector or the position vector. Same. So if the velocity vector of the liquid is, or the electromagnetic liquid is q, r vector divided by r to the power 3 dot product of the area vector. Area vector is nothing but whatever is the area and unit vector. The area is 4 pi a square, 4 pi a square, and area vector and radial vector r vector, they are in same direction. So it becomes q r vector or q into r unit vector divided by r to the power 3. Q r unit vector divided by r square into 4 pi r square. R unit vector, R unit vector, R unit vector gone, R square as R square gone. 4 pi Q is the net flux. Now we have seen for the sphere, if you watch closely, then the flux that is coming out of a spherical shape when a charge Q I kept at the center, then it is independent of the radius. The flux that is coming out from the surface is 4 pi Q, not R. There is no R here. So it is independent of the radius. So the flux that is coming out of a sphere is Q into 4 pi. Q into 4 pi. Okay, that is the flux that is coming out of the surface. What is flux density? 4 Q 4 pi divided by volume of this sphere, 4 by 3 pi r q. That is the volume of a sphere. Flux density. If this is the flux coming out of the surface, if I divide by the volume of the entity or shape, it is called flux density. Per unit, per unit of the volume, how much is the flux that I can measure? Okay, flux I know divide by the volume of the entity. Per unit volume, how much flux is coming out? That is 4 q into 4 pi divided by volume 4 by 3 pi r q. Pi gone, 4 gone, 3 went up. Okay, it 3q by r to the power 3. That much is the flux per unit volume. This is called flux density. This is called flux density. Let's go and calculate the flux density formula. Okay, flux density formula. If I have a 3D shape and if I'm able to calculate flux on the surface of the shape, how much is the liquid passing through the surface? If I divide it by the volume of the shape, then that will be called flux per unit volume. How much is the flux per unit volume? Okay, let's proceed. Okay, now in that sense, we are proceeding in that sense, let's consider this is a x-axis, this is y-axis, this is z-axis, this is origin. Now at origin, okay, I'll bring a really cube. Okay, I'll have a cube. Okay, now okay, I have a cube. I really have a cube. Now consider, is it big one? This is better one. Okay, I have a cube. I have a cube that is kept at the origin. At the origin. Okay, this is origin x-axis, y-axis, z-axis. At the origin, I have a cube. At the origin, I have kept a cube. Now cube means length, width, and height. They are same. Now cube width is 2 delta x, where delta x tends to 0. 2 delta x. Cube length is 2 delta x, or cube length is delta x. Now consider it is delta x. The cube length is delta x. Cube is centered at the origin. So along the x-axis, the length of the cube is centered at the origin. Cube is centered at the origin. So this point is the origin. This is z-axis. This is x-axis. Actually, this point is inside the cube. Okay, if I take out, then this is x-axis, this is z-axis, and from center of it, this is y-axis. This length is delta x, and delta x. Now it makes sense. There is a cube. Now there is a cube that is kept. There is a cube that is kept at the center. There is a cube that is kept at the center. There is a cube that is kept at the center, and then its length, width, height is delta x, delta y, and delta z. Now consider there is a liquid that is flowing along x-axis. This is origin. This is origin. This is x-axis, and this is minus x-axis. Now a liquid is flowing along the x-axis. Okay, liquid is flowing along y-axis, liquid is flowing along the. I mean, there is a liquid that is flowing. It has x-axis component, y-axis component, and z-axis component. Tell me the velocity of the liquid. Velocity of the liquid is F vector, capital F vector. This is the way we denote vector field. So capital F vector equal to F1 capital F1I plus F2J plus F3K. Now along the x-axis F1 is flowing, along the y-axis F2 is flowing, along the z-axis F3 component is flowing. Now if there is a if this is the origin, then this is the origin, then this is the side of the cube, one side. Another side of the cube is here. This distance is delta x by 2. Then this is one side, that is delta x by 2, another side is below delta x by 2. Okay, one is delta x by 2. I mean, this is delta z by 2. This is delta z by 2 gap, and this is delta y by 2, and this is delta y by 2. These are the six sides of a cube. Now let's consider this side of the cube. This plane is yz plane. So the length and width of the cube is this side is delta y and delta z. F1 is the velocity vector that is entering this side, F1. Now if I calculate the flux here, that is F1 delta y delta z. Make sense? F1 delta y delta z. If I take these two sides of the cube, these two sides of the cube, these two sides of the cube, this side has area vector along minus x-axis. This side has area vector along plus x-axis. Makes sense? We have always showed like this. The area vector is along x-axis, area vector is along minus x-axis. Now this is F1 vector hitting the surface. The surface is in yz plane and dimension is delta y delta z. Now the flux will be F1 delta y delta z. Velocity into area, but it will be in minus I direction. So flux is F1 delta y delta z minus I. Similarly, flux that is coming out from here is F2 F1 delta x, sorry, F1 here the F1, the field what we are saying, that is F at minus delta x by 2. F1 at F1 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 at minus delta x by 2. This F1 is changing, right? I'm considering the F1 component of velocity vector. If velocity vector is capital F equal to F1I plus F2J plus F3K. F1, consider F1 is kind of, if it is F1, then F1 is going along x-axis. At any point, if I take F1, then F1 I can take at particular point in x. Here F1 at particular point in x. So F1 here is at minus delta x by 2. So F1 at F1 bracket minus delta x by 2. F1 bracket minus delta x by 2. Okay, and then delta y delta z minus I. Delta y delta z minus y is the flux here. Same thing if I calculate here F1 at delta x by 2, not at minus delta x by 2, delta x by 2. F1 at delta x by 2, delta y delta z I vector. Okay, net flux in F1 at minus delta x by 2, delta y delta z, because this is yz plane. If I take a small, if the side of this cube I have taken is delta y into delta z. So it becomes f1 minus delta x by 2 minus delta y delta z minus I plus f1 delta x by 2 delta y delta z I vector. Now net flux through this surface is addition of these two. Then it becomes f1 at delta x by 2 minus f1 at minus delta x by 2 delta y delta z I vector. That's it. Let's divide it by delta x and multiply it by delta y. Whatever I have, I can divide it by something, I can multiply by the same thing. If that is the case, it becomes f f at delta x by 2, f at delta x by 2, delta y delta z minus f at minus delta x by 2, delta y delta z multiplied by delta x. So here also delta x will come, here also delta x will come. Divide by delta x, I vector. Okay, if that is the case, divide by I vector. Anyway, okay, I, I am sorry. Okay, the flux has no I vector, means velocity of this liquid is F1 I vector. It is going in x direction, then it is F1 I. I have taken ith component as F1 I, and this surface is delta y delta z minus I, delta y delta z plus I. So dot product if I do, I will go away. Now anyway, whatever we have net flux at these two surfaces is F1 delta at delta x by 2 minus F1 at minus delta x by 2 divided by delta x whole multiplied with delta x delta y delta z. If I have something called F f at f at f at x plus delta x, f at x plus delta x minus fx divided by delta x. This is exactly at dfx by dx, df by dx, df by dx. It is understandable, right? Means if I have an equation called fx plus delta x minus fx divided by delta x, that is dfx by dx, as per the first principle of differentiation. Now here we have f1 at x plus delta x minus f1 at minus delta x by 2. Sorry, f1 at delta x by 2 minus f1 at minus delta x by 2 divided by delta x. It is exactly same as what we said. The difference between delta x by 2 and minus delta x by 2 is delta x only. Same as x plus delta x minus fx by delta x. Same thing. Okay, if only thing is x, I have taken here origin. X, I have taken here origin. I could have taken the cube that is centered at any x point. Consider if I take the cube, whatever cube I was showing, the cube is centered on the x-axis at any point x, or it is centered at any point x comma y comma z, at any point x comma y comma z. Then left side is x minus delta x by 2, and right side is x plus delta x by 2. If I take f1, then this flux on this side and this side, it becomes f1 x minus at x minus delta x by 2 minus f I'm sorry, f1 at x plus delta x by 2 minus f1 x minus delta x by 2 divided by delta x. Okay, so I would rephrase it what I had started. For simplicity, I made my cube centered at the origin. If I make my cube centered at the origin, there are two sides of it. One where the cube length, width and height is delta x, delta y and delta z. This side of the cube is at minus delta x by 2. This side of the cube is at plus delta x by 2. Up is at delta z by 2 and down is at minus delta z by 2. This side is minus delta y by 2 and this side is at delta y by 2. This is called YZ plane, YZ plane. This is called xy plane, and this is called xz plane, xz plane. Now, if there is a liquid that is flowing, its velocity vector is capital F, that is F1i plus F2j plus F3k, then F1i is going along the x-axis. It is hitting this side of the cube and this side of the cube. This side of the cube has minus I vector. This side of the cube has plus I vector. Now, this side of the cube has area as delta y delta z, yz plane. Now, this is F1 at minus delta x by 2. This is F1 at this point is at delta x by 2. Here the flux is F1 at minus delta x by 2 delta y delta z minus I vector. Here the flux is F1 at delta x by 2 delta y delta z I vector. If I want to calculate the net flux, then this upside and this side, there is no flux. They are perpendicular to the F1. So only this side will come into the picture. Net flux is F1 at delta x by 2 delta y delta z minus, because it was minus I vector, minus F1 at minus delta x by 2 delta y delta z. Let multiply it by delta x and divide by delta x. Now it will come as F1 delta x by 2 delta x delta y delta z minus F1 at minus delta x by 2 delta x delta y delta z divide by delta x. Now take out delta x delta y delta z. Now it will become F1 at delta x by 2 minus F1 at minus delta x by 2 divided by delta x. This is exactly same as df1 by dx. Okay, now someone can take it as, now I had taken it the cube centered at the origin. Let's take cube centered at the xyz. The left side is x minus delta x by 2, right side is x plus delta x by 2. In that case, it will become f x plus delta x by 2 minus f1 x plus delta x by 2 minus f1 x minus delta x by 2 divided by delta x whole multiplied by delta x delta y delta z. This term is exactly df1 by dx. Same thing. So the net flux at this side and this side is df1 by dx into delta x delta y delta z. Similarly, if I add other y-axis and z-axis, it will become df1 by dx delta x delta y delta z plus df2 by dy delta x delta y delta z plus df3 by dz delta x delta y delta z. If I take all together, then net flux is df1 by dx plus df2 by dy plus df3 by dy whole multiplied with delta x delta y delta z. Delta x delta y delta z is nothing but the volume of the cube I had taken. So net flux is df1 by dx plus df2 by dy plus df3 by dz multiplied by delta x delta y delta z. If this is the flux, then flux density is flux divided by the volume. Then it becomes df1 by dx divided by volume is, okay, it becomes df1 by dx plus df2 by dy plus df3 by dz whole multiplied with the delta x delta y delta z divided by the volume is delta x delta y delta z. It becomes the flux density. What is the flux density in the cube? I have calculated, this is cube, consider this is cube, I kept it. This is the cube. If this is the cube and all along the cube the net flux is df1 by dx plus df2 by dy plus df3 by dz delta x delta y delta z, then net flux per volume unit volume is, I have to divide by the net volume, that is delta x delta y delta z. The flux density is del df1 by dx plus df2 by dy plus df3 by dz. Oh, what are you talking? df1 by dx plus df2 by dz y plus df3 by dz. This is flux density. Yes, this is flux density. No, no, this is divergence. This is not flux density. Anyone would kind of interrupt. This is divergence. What do you mean by divergence? Divergence means if this is centered at the origin, This is centered at the origin. And then divergence means if it is something, if I keep a shape that is centered at the origin, and then what is the flux that is changing along x-axis? If here the flux is F1 into area, F1 into area. This side flux is again F1 into area. And consider the F1 is changing. The F1, that is the velocity of the liquid, that is F1. X component is F1, Z component is F3, and Y component is F2. The F1, here if I calculate the net flux, and here if I calculate the net flux, typically it will be 0. This side there is no flux because of F1. So here F1 into area, here F1 into area. Area vector here, area vector is here. So net flux is 0 because F1 is same. Okay, if F1 is not same, here the F1, the liquid that is entering at F1 velocity and liquid that is coming out at different F1 velocity. Here F1 is different and coming out F1 is different. If that is the case, the net flux at this side and this side are different. I have given an example already in the past video. Consider the liquid is entering here at 10 meter per second, and this area is 1 meter square. Here area is 1 meter square, but it is coming out as 12 meter per second. 12 meter per second. In that case, the throughput, the net volume of the liquid that is coming out here is 12 meter cube per second, whereas liquid entering here is 10 meter cube per second. Means at the center of this there is a liquid source, there is energy source. We are talking about the energy calculus. Means the energy that is entering from this side and energy that is coming out from this side, they are different. It means that at the center we are mixing some energy. Mixing of energy is called divergence. Divergence in the sense that how much is the divergence of energy that we are seeing. Divergence means how much is the energy that is contributed by the origin. How much is the energy that is contributed by some energy source kept here. There is an energy source that is kept here, and from that energy source I am getting liquid, electromagnetic liquid or electromagnetic radiation that is coming because there is an energy source here, coming and touching this, and then it is passing through this cylinder and coming out of here. But the flux that is coming entering, the velocity into area, and flux that is coming out, velocity into area, are different. And if this flux is more, then at the center of this cylinder I have another energy source. Because of that energy source means it is mixing more liquid out there. If it is more mixing liquid out there, then the liquid, the gush of the liquid that is passing here, the velocity is increasing. The velocity is increasing, then this side the throughput is more. So blindly I can say that if entering flux and exiting flux is more than entering flux, then certainly there is an energy source in the middle. That if there is an energy source that is diverging energy, that is throwing energy in all direction, then this is called divergence. Divergence means an energy source which is diverging the energy, like sun is a divergence energy source. Black hole is also has divergence but in reverse direction. Okay, so if I have df1 by dx, means f1 is changing. If f1 is changing as we go along x-axis, df1 by dx is not 0. If the liquid that is entering here, same liquid is coming here, means same velocity it is coming here, then, and this area, surface area is same, then there is no df1 by dx. The velocity of f1 is not changing if I go along x-axis at a particular point. A particular point is origin. Near the origin, because this length I am taking here, consider it is infinitesimally small, and it is so small that it is centered at the origin. Means at the origin point, little bit around here and there is no change in f1 if I move along x-axis. df1 by dx is 0, or if df1 by dx is there, if velocity is changing, f1 is velocity, if velocity is changing when the liquid is moving along x-axis, then dF1 by dx is positive. In that sense, there is some energy source is in the path. Because of that, only dF1 by dx is changing. Means at that point where energy source is kept, that point is called has divergence, because energy is emanating from there and it is adding the velocity of whatever the velocity of the electric field that is coming, entering here, it is adding to it and more is coming out. So at that point, divergence is positive, it is adding. Consider this side, it is entering with F1 velocity and it is coming out with less than F1 velocity. Means at the center, there is some sink point is there, some hole is there, and there liquid is coming out. There is some hole, pipe there, and liquid is coming out. If liquid is coming out, the liquid velocity here it will be less because liquid is dripping. Liquid is dripping from here. There is a hole there. That is a black hole in the universe. Black hole where energy, whatever energy is flowing, electromagnetic radiation, they are getting, they are entering into the black hole. So black hole has divergence but in negative side, whereas sun has divergence in positive side. Electromagnetic radiation are gushing from the sun. Similarly, if velocity vector from here, this side is more, then at the center, there is a positive divergence energy source is there. If here entering velocity is more, out is less, means divergence at the center is there, but it is negative in the sense it is sucking the liquid. Or if it is same, F1 here and F1 here are same, then dF1 by dx means at the on the path there is no energy source either positive or negative. So in that sense, dF1 by dx, F1 is not changing along x-axis. dF1 by dx is 0. Or dF1 by dx is positive if divergence is positive. Positive divergence energy source is there. Or dF1 by dx is negative when hole is there, black hole is there. Okay, if that is the scenario, the flux density what we calculated is dF1 by dx plus dF2 by dy plus dF3 by dz. This hole is actually divergence at a particular point. dF1 by dx, how much F1 is changing along x-axis. dF2 by dx is how much F2 is changing along y-axis. dF3 by dx, how much F3 is changing along z-axis. If I add all three, it talks about the divergence at the center or whatever. dF1 by dx may be algebra. dF2 by dy may be algebra. dF3 by dz may be algebra. If you add all these algebra, there will be algebraic term in x, y, z. If you set x, y, z as 0, 0, 0, then you will find divergence at origin. Whatever is feasible, if you want to calculate at any point, that is divergence. Can you give me a real life example? I have already given real life example. Consider there is a velocity vector. Consider there is a velocity vector called minus xi plus y by 2j plus z by 2k. There is a, what is velocity vector minus xi plus y by j plus zk? Anyone now? It is your imagination, you can imagine. Along the x-axis, y is 0, z is 0. Along x-axis, it is minus xi. In that sense, minus x means along the positive of the x-axis, it is going towards origin. That is minus x. Along the negative of x-axis, it is again going toward the origin because it is minus x. Okay. Now along the y-axis, it is y by 2, where I component is 0 and z component is 0. This is y-axis. If this is y-axis, little bit I am tilting now. If this is y-axis and this is the origin, y by 2. Y by 2 means from the origin in the positive of the y direction, it is going like this. In the towards the negative of the y direction, since direction is negative and it is y by 2, it is going in the negative direction. From origin, it is going this direction. From the origin, it is going this direction. This is showing positive divergence as in y-axis, where in x-axis, it is minus x. So from in x-axis, it is going towards origin, and in minus x-axis, it is going towards origin. It has negative divergence. So liquid is coming toward the origin on x-axis. liquid is going out of the origin along y-axis. Similarly, on z-axis, liquid is going out of the origin, z by 2. So minus xi plus y by 2j plus z by 2k, where on x-axis liquid is coming toward x-axis. On y-axis, liquid is going outward of the y-axis. Along z-axis, liquid is going outward of the z-axis. What is the net fundamental? If you see, it is minus x. The liquid is coming as minus x. In the y-axis, liquid is going out as y by 2. Means half of the liquid, what is coming to the origin from the x-axis, it is going towards y-axis. And rest of the half of the liquid is going towards z-axis. What about the origin? There is no liquid out there. Origin is just behaving as a router. Whatever liquid is coming from the x-axis, half of it, it is it is distributing along y-axis, it is distributing along z-axis, half half. So net divergence at the origin. If someone talks about z-axis, if someone is standing on the z-axis, he will see, oh, origin has quick divergence. See, I am getting liquid at the origin. From the origin, liquid is gushing in the z direction, positive and negative. So there is a positive divergence at the origin. If someone is standing on the y-axis, he will say, yes, there is a positive divergence on origin because liquid is gushing out of the origin. But hidden truth is whatever liquid is gushing out of the origin in y direction and z direction, that liquid is coming from the x-axis and that is distributed. So net divergence at the origin, because there is no liquid source at the origin, neither there is any drippage. So it's just distribution. So df1 by dx plus df2 by dy plus df3 by dy. How much f1? The velocity is changing along x-axis plus y-axis plus z-axis. It becomes minus 1 plus half, 0. Okay, divergence at any point is how much is the velocity x-axis component is changing along x-axis. Velocity x component is changing along x-axis. Velocity y component is changing along y-axis, whereas velocity z component is changing along z-axis. If you sum it, if you add it, that is the if you add it, because whatever I am talking, df1 by dx, df2 by dy, df3 by dz, all are algebra. If you add it, it will be algebra. Now set any point. If I set origin, then set x, y, z as 0, 0, 0. Now see what is the value. If that value is positive, then at the origin, some liquid source is there. If it is negative, then at origin, some black hole is there. If it is 0, then at origin, there is no energy source. Origin is just routing whatever coming to it. These explanations are not available anywhere else. This is typically called divergence. Divergence at any point is same as flux density. Flux density means if I have a cubical region or I have a cubical region or a spherical region, what is the flux of this region? What is the around the surface of this region? How much is the flux that is coming out? Divide it by the volume, that is flux per unit volume, flux density. Flux density is same as divergence, because flux density we calculated as df1 by dx plus df2 by dy plus df3 by dz, delta x, delta y, delta z for a small q. Divide it by the volume, delta x, delta y, delta z. All gone, and it came as df1 by dx plus df2 by dy, df3 by dz. Okay, I don't trust you. Someone would say, very nice. But you remember you talked about the net flux is velocity vector dot product with the area vector. Yes, I remember. Velocity vector dot product with area vector. Area vector is same as d of area position vector, right? Now, if I talk about Cartesian, d of position vector is d of p. This is absolutely not there anywhere. D of position vector is dp by dxy plane into dxy plane. dp by dxy plane is dp by dx cross dp by dy. Position vector is xi plus yj plus zk. dp by dx cross dp by dy is same as I plus dz by dxk cross j plus dz by dyk. It came as minus dz by dxi plus minus dz by dyj plus k dx dy, if you remember well. Can you tell something about it? Okay, what is your velocity vector? F1i plus F2j plus F3k. Dot product with all three dx dy. Dot product with dx dy minus dz by dxi plus d, dx dy minus dz by dyj plus dx dyk. Now whole dot product, if you take dot product, it becomes F1 dx dy dz by dx plus F2 dx dy dz by dy plus F3. Okay, now I am free to multiply it by dz and divide it by dz. If I do so, it becomes F1 into dx dy d by dx, just d by dx minus f1 dx dy, just d by dy. Okay, plus f1 f1 dx dy dz, because I'm multiplying by dividing by multiplying by dz dividing by dz. Okay, but I'm sorry. I believe I made some mistake. Okay, so I'll try again. Okay, so the full flux calculation is F1 dx dy minus dx by minus dz by dx minus dz by dx I vector plus F1 dx dy F2 minus dz by dyj plus F3 dx dyk. Now multiply it by dz and divide by dz. If that is the case, then first one dz will go away, second dz will go away, and third by dz will come into the picture. Now if you take it, then it becomes f1 or f1 dx dy dx dy d of dx I vector, d of dx I vector is gone because I did dot product, I vector is gone, minus f1 dx dy d of dx plus minus f2 dx dy d of dy. Okay, f2 whatever minus, sorry, now plus f3 dx dy d of dz, that will come into the picture. If you settle it, it becomes dx dy minus dx dy df1 by df1 by, so I had multiplied by dx and divided by multiplied by dz and divided by dz. So if I multiplied by dz divided by dz, the first one was dz by dx, divide by dz gone, so numerator dz remained into the picture. So first now it becomes dx dy dz. I believe I am all right. Okay, let's try again. So at the beginning I had f1, so I'm sorry, dx dy, or keep the dx dy outside only. For everything, keep it outside. Dx dy. Now multiply it by dz and divide by dz. So it becomes dx dy dz divide by dz. Now dz I am going to divide everywhere. First is f1 minus dz by dx. If you divide by dz, it becomes minus d by dx. F1, it becomes minus df1 by dx. Next is F2 dz by minus dz by dy. Divide by dz, it becomes minus d of dy, or becomes minus df2 by dy. Next was F3, only F3. Now F3 divided by dz, df3 by dz. Now whole becomes minus df1 by dx minus df2 by dy plus df3 by dz. Dx dy dz is the net flux. If you make division by the flux by the volume, then it becomes df1 minus df1 by dx minus df2 by dy plus df3 by dz. It is not exactly df1 by dx plus df2 by dy plus df3 by dz, but it is giving, no, it is a kind of assignment how you can take out minus, but integration over whatever it is. If we have taken dx dy dz as the very small entity and that is it, then integration of x will be minus whatever, minus x by 2, x by 2, minus y by 2 to y by 2, and z is minus z by 2 to z by 2. Now it will settle down in that fashion only. Delta x, delta y, delta z. Now divide by the volume, then the flux density will become minus df1 by dx minus df2 by dy plus df3 by dz. But the actual expectation is df1 by dy dx, df2 by dy plus df3 by dz. Now someone can settle it. So through the primitive calculus, that was velocity vector dot area vector or velocity vector dot d of position vector, through that we can calculate the flux. From there also we can calculate the flux density. Minus minus, that has to be settled down. Okay, we will do tons of example on this because this is the last in the energy calculus. So this is energy divergence. Energy divergence means at what point, at a particular point, if I'm calculating flux density, then flux density is same at that point. What is the nature of the point? Divergence is zero, means there is no energy source kept there. Divergence is positive, means there is energy source kept there. Divergence is negative, means there is a black hole, energy sucker is there. Anyway, don't mind supporting us. Plus 91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. Plus 91 is the India country code. Okay.